Hi, everyone. My name is Jonathan Racinos, and just want to welcome you to the Konveyor community event. So if you're not already subscribed to the Google group, I would encourage you to go konveyor.io, go to forum, and then click join group. This way you'll stay on top of any future meetups that we have. You can see the tools that are being worked on upstream, and you can also just discuss a little bit further after the events are over. And as for today's presentation, if you have any questions, just go to Q&A. We'll be doing some polls, and we post a link to a survey just to understand a little bit better about what type of problems you're facing. And that way we know what type of information we should be providing at these meetups. So with all that said, I'll be handing over to our presenters, Marco and Fabian.
Thank you, Jonathan. Hi, my name is Marco Birube. I'm the product manager for the migration toolkit for virtualization. And I have Fabian Dupont with me this morning to talk about the new tool that's called MTV, which is about migrating virtual machines to OpenShift virtualization. Fabian, can you go to the next slide? So first of all, let's talk about how MTV is actually upstream under the Konveyor community, which is actually called Forklift. So in Konveyor, we have multiple projects, right, that are all about migration. So we have Crane that becomes MTC, and we have WindUp that becomes MTA. But today we're going to focus on the MTV downstream version that is upstream is called Forklift. So this is the same tool, but this is the tool that we work under the Konveyor community upstream. This is all we do all the work. And then a few times a year, we'll release a downstream version that is going to be called Migration Toolkit for Virtualization. And this tool is, as I was saying on the previous slide, is about migrating virtual machines to OpenShift virtualization. So at first, we'll support VMware, but we will also support in the future Rev and OpenStack to help migrate those VMs all the way to OpenShift or KubeVirt. Next slide. So the main purpose of the tool, as I was saying, is migrate VMs, but on top of it, it's to migrate VMs at scale. So the tool has been designed to help migrate a large amount of virtual machines. So we're trying to make it as easy as possible using this tool to actually first map your environment. Fabian will do a demo later on, so that'll be a lot more clear, but obviously connect to the different providers, then map your environment on how you want those VMs to be migrated, and then finally migrate those VMs at scale using migration plans. And on top of it, something that we learned from our previous migration tool, IMS, is we're adding migration analytics, but in this case here, we're going to have migration analytics directly inside the tool. Before it used to be in the cloud only. Now it's going to be actually on-premise inside the tool. And the intent of migration analytics is to help you understand the compatibility of those VMs. And if we detect any potential compatibility issues, then we will let you know directly before you even try to migrate them. So obviously the tool is probably not going to be perfect even more day one, but this is something that will just get better and better over time. As we can understand more compatibility issues, then we can add those rules inside the tool and let you know actually sometimes with warning of something that should actually be considered or will change during the migration process, or sometimes as critical. So this is going to come as a step 2. So the first use case will be the mass migration, and migration analytics will follow just a little bit after that. Next slide. So this is just a quick roadmap slide. So the intent is so right now we're working in Forklift upstream, right? And so in January, we released the first downstream version, which is going to be called MTV 2.0. And it's going to be a tech preview version, as this is the first time that we'll have a build all put together. And obviously this first version will be mostly just for migrating from VMware and will be mostly targeting migration at scale of those virtual machines. On GA in April, then we are expecting to add additional capabilities. Actually, the main one was going to be warm migration. So there's a difference between cold and warm migration. So in the tech preview, we're only going to have cold, and at GA we'll have warm. And the difference between the two is the amount of downtime during the migration process. So during a cold migration, the VM is shut down at the beginning of the migration process and rebooted at the end. And with warm migration, we can start copying the disk as soon as you start migrating without shutting down the VM, and only reboot at the end where we're pretty close to having 100% of the disk. Then we can just flip the switch at that time, so the amount of downtime is much shorter. It could take longer to migrate as there's more data that might have to be copied, as the disk could change during the migration process. But so cold will still be there as the fastest way to migrate, and warm will be there to reduce downtime. As well as migration analytics, as I just talked about. Actually, right now, we are hoping to have this maybe potentially before GA in a tech preview version 2, but this is something we're still planning for. But in worst case scenario, we'll have it at GA in April. But we're hoping to have it sooner if it's possible. That's it, Fabian. So I'll leave it up to you now to talk about the architecture and all the technical details about all the tool work.
Thank you, Marco. Quickly, the first slide I have is a really high-level architecture diagram. So here, basically, I'm showing the components we're using or the ones we have developed during the creation of Forklift. On the left, you've got the VMware provider, and what we're trying to do is migrate VMs to OpenShift virtualization or KubeVirt for the upstream versions. Here, we are reusing components that were part of KubeVirt. So at the bottom of the diagram, you've got OpenShift VM import operator. That one has been actually created by the KubeVirt team. So it's already working to migrate VMs from Rev to OpenShift virtualization. In our case, what we've done is we extended this pipeline for migration to support VMware. So our experience with IMS, our previous tool, allowed us to leverage a great chunk of code, or at least the logic to use VDDK for transport. And we also enhanced the pipeline to add a conversion step because VMware is using the VMware hypervisor ESXi which is not compatible with KVM. So the drivers have to change during the conversion. So for that, we're reusing a tool that you probably already know, VirtV2V. And in that case, we use it during the transition. So we copy all the disks, and at the end, we run a conversion of the operating system. So you can see a few custom resources there. We have the notion of mapping, migration plan, and migration run. So actually, the most important one is the plan there. So the plan is actually what we use to group VMs that we want to migrate at the same time. So in a plan, you've got basically a list of VMs plus additional information on how we map the source storage and networks to the destination storage classes and networks attachments. We support both the pod network and multi networks, exactly like KubeVirt. And because we thought that the users may like to actually iteratively create the mappings, like you're doing a first plan, you run it, you have mapped the source and destination for those VMs, then you create a new plan, you can then reuse the existing mapping in that new plan. So you can save some time when creating new plans. The migration run is actually an iteration of the migration plan. So it's been created because, for example, the plan can fail, or at least one VM in the plan can fail for various reasons. So then, say the VM was not stopped correctly, you can go back in VMware, stop the VM, or change something in the configuration, and then run the plan again. So in that case, we have a second iteration of the plan. And for each VM, what we're doing when running a plan is actually create a VM import CR. So the VM import is one that comes from a VM import operator, and it describes the migration of a single VM. So when running a plan, we're actually running all the migrations in parallel, and because of the architecture of VM import operator and KubeVirt, all the disks are also migrated in parallel. So we are using the maximum throughput for that instead of queuing them in series. I think that better than words, I can show you a demo. Marco, can you just confirm you see my screen correctly and it's big enough?
Yep, all good.
Good. Thank you. So here what you can see is the basic OpenShift console. I'm just connected, so I'm an admin, but it should work. It will work as an admin in the first iteration. And one of the questions we have for you is with what persona is going to use it. Today we're designing for administrators because usually infrastructure administrators have access to the VMware. But it might be different in your case. So that's something we would be curious to know for the next versions. I also have a window for my VMware environment. We currently have some issues with with migrating Windows VMs. We found this morning. It's going to be fixed hopefully today. But I'm going to migrate this VM. This one is a RHEL machine. Nothing fancy, just running, having an IP. I'm starting it on the VMware side, and it's basically working. In the meantime, I'm going to show you how to actually install the operator. So we have the operator menu. We have an operator hub operator. So here we go, and we have a list. So from there, I'm going to write fork and my operator there. So Konveyor Forklift operator, the name, and is provided by Red Hat, but also by the Konveyor community. So far from the capability level, we are doing basic install and seamless upgrades. For this kind of very technical operator, the full life cycle is less interesting, so we focused on the upgrades. To install it, I just click on install and I approve automatic update. I install it in a OpenShift migration namespace. And I'm using the development channel because we have no release so far. So installation is as easy as that. OpenShift is taking a few seconds, and then I can go to see the install operators. So the installation is in progress. And then when it's succeeded, I have actually the operator, but the operator is not handling any, it has created the custom resource definitions we need, but the controller to actually handle those custom resources has not been deployed. So that's the last step we have to do before switching to the Forklift UI. So here I just create an instance. And if you want to see what happens, actually the operator is reconciling this instance. It's going to create two more pods, one for the controller and one for the UI. Controller is coming. And the UI. So here I'm cheating a bit. I know exactly the route of the for the UI for the UI application, so I can go directly to it once my UI container is running. Now, so here I'm connected to the UI. You've seen the mockup earlier. So that one is a bit, there's a bit less features, like you don't have the connection to for the analytics. And here you can see that we already have a provider. When we do the installation, we actually create directly a provider for the OpenShift virtualization platform on which we are running. So this way, you don't have to create it. You just need a VMware provider. So let's add one. So it's a provider type VMware. I've run that a few times, so the data is there. The only one I don't have is the thumbprint, which is the SSL fingerprint, because we want to check the SSL certificate for VMware. So we can add it. And now we've got another tab for VMware provider. So what happens when we create a provider, it actually triggers the inventory of the provider in the controller pod. So the controller pod has two containers, one which is the actual controller dealing with the custom resources, and the other one running an inventory component. So connecting to vCenter, gathering the list of hosts, VM, networks, and this way it is actually updated in real time based on the VMware events. So we can rely on it for the migration. The next step is just to create a migration plan. So I go to migration plan, create. I'm going to call it demo. My source provider is the one I've created for VMware, and I target my current cluster for OpenShift. I can select one of the existing namespaces, or I can start typing, and I select to create a new namespace for my application. On the next step, I can select the VMs I want to migrate. So here I know it's running on the ES type 13, but we also have the ability to sort by folders. So mine is at the top of the data center, so I prefer selecting the host. And from here, my VM, the one we've seen earlier, is fdupont-test migration. So confirm. I reset here. It's running. So just picking that one. Well, the main reason I just take one is the bandwidth we have in this lab is quite low. So if we don't want it to take too much time, I prefer selecting just one. What happens is, well, let's do it different. I'm going to take another one. Just a Windows server. This one, I'm going to unselect them afterwards. Oh, they are connected to the same network. So anyway, what you see that the source networks have already been identified. So the only thing we need to know for the mapping is to select a destination. Let me go back to the selection. I don't want those ones anymore. I talked about having mappings that we can reuse. What I can do is save the mapping for later use. So after that, if I create another plan, I will have an existing mapping. So you could see that the two other VMs were connected to the same network. So in that case, I could actually reuse the mapping fully. You can also go in the mappings menu here and create the mappings before creating the plans if you have a lot of networks and you already know one by one how you want to map the networks and storages. Here for the mappings of the storage, I'm creating a new one and mapping to a storage class. My lab is running on top of OpenStack. So by default, I have a CSI Manila Ceph storage class, which is created using Ceph as a backend for Manila. And another one which is standard using Cinder. In that case, I know that the Ceph is quite small while the standard has lots of space. So I'm taking the standard. I can save it again. Really, I call it map demo. And now I've done all the mappings. Selection is done. I'm almost ready to run the migration. So I have a quick review, reminding which VMs how many VMs I'm going to migrate from, to which namespace, and how the mappings were done. I just have to finish. So we do some tests on the plan. We validate that the plan is correct. So we have all the information that the mappings are actually going to work. And from there, I can just start the migration. So what it does technically, it creates a migration CR. So the one I mentioned earlier, which is an iteration of the plan. So my plan is running. It's run, well, the one VM is actually migrating, so it's still 0 out of 1. But if I want more details, I can click on demo, and I have information about the migration. So for this VM, we only have 2 steps. We're planning on adding more in the future to allow for using hooks at some specific stages of the migration, like before cutting down the VM, we may want to run a playbook to pre-configure the VM for the migration. And after the migration, we could want also to run another playbook to reconfigure the VM or change some parameters of the say load balancer or something. So here we only have 2 steps: transfer the disks and convert the image to KubeVirt. So the second one is using Virt V2V. From there, it's going to take not so long. You can see I'm already at 4 gigs. So on this VM, I actually have two disks. One is empty, so it was really fast, those 4 gigs. But if I go back in the OpenShift console, let's do some deep dive quickly. It has created my app project. And in my app, I actually have 1 pod running. And you can see that the name is importer, the name of the VM -r disk 1. So it's migrating the disk of the VM. For that, we're using VDDK, the recommended way by VMware for transferring data from VMware. It's proprietary, so we can't really ship the VDDK library. One step you have to do before that is creating an image in your own registry. But once it's done for all the VMs. So it's just one prerequisite step. And if you want to see a bit more, we can just show you the logs. It's actually converting the disk. We are 8% of the conversion. We're actually using QEmimage to copy the disk. In the next iteration of the beta, we will be using libnbd, which should provide some performance enhancement, and also more control over what is transferred when we do warm migration. Because I'm running OpenShift virtualization in this cluster, I have that specific menu, virtualization, and we can see that the VM has already been created, but it's in the status importing. Basically, it allows us to possibly cancel the import. We can also change the annotation. Starting it, I think is not a good idea right now. And from a storage point of view, dynamically at the beginning of the conversion, we're creating a data volume, which is an overlay custom resource on top of the persistent volume claim. So here, my VM has 2 disks, so we have 2 persistent volume claims, and they have been dynamically, the persistent volumes have been dynamically created by Cinder provisioner and bound to the VM. So let me come back quickly to the presentation. I can give a bit more details on the migration process. So as we've already seen, we try to keep it quite simple. Most of the work already existed from a flow point of view. We had to extend that flow to support VMware, but the idea was already there. What we're adding is an orchestration layer where we provide the notion of plan to group VMs, possibly add more options during the migration, like the warm migration is one of them. having hooks for the VM is another one. They will all have the same hooks, but they would be run separately. And then from there, we can actually see what is happening in VM import operator. There, we're providing the credentials to the VMware API plus the VMware URL. And from there, for each disk of the VM, we're creating a data volume. So the data volume is coming from KubeVirt 2. It's another CR, as I mentioned. And the containerized data importer controller will actually trigger an importer pod. So the one we've seen earlier with the progress, that pod is actually it started with a PVC attached to it, and in our case, it will use PDDK to transfer the disk on the destination persistent volume. Once that's done, once the copy is finished, we come back to the conversion, to the next step, which is running the conversion pod. And the conversion pod is going to be started with all the data, all the PVCs attached directly. So the first step is actually quite like a map operation where we are triggering all the copies at the same time. And then we are doing a reduce with a conversion where all the disks have to be present because ViRT V2V needs to know how many disks, how they're configured, and also to be able to properly install the drivers and configure the VM. And then from there, we actually finalize the virtual machine instance with the PVCs. And we can start the VM using the KubeVirt controller to generate a virtual machine pod, so a pod in which the VM is running. This is the overall process, not very complex. We try to keep it as simple as possible. And over time, Marco mentioned that we will have the warm migration. So the warm migration is actually going to be at the data volume and the CDI controller level, plus the VM import. So we will use change block tracking from VMware to actually get a list of change blocks between two timestamps. And on the first time, we actually copy the whole disk of the VM with the biggest amount of data, probably the biggest amount of data. And then every X minutes, we create a new snapshot for change block tracking, get the list of change blocks, and only copy the difference. With that process, normally, in 90% of the VMs, the amount of data will decrease over time. And at some point, it will be close to zero. So doing the conversion takes about 2 minutes. So the downtime should be decreased to about 5 minutes instead of possibly hours, depending on the size of the disk to transfer. So that's in one of the next iteration. We're currently creating the PRs in both VM import operator and CDI. Let me see if my migration is finished. No, not yet. Only 13%. Maybe we can look at the questions.
Yeah, Fabian, a question came up about templates. I'm not sure what the answer is. So one of the questions was, can you migrate VM templates?
Today we don't have a specific flow for templates, but from the VMware point of view, a template is a VM with just a specific flag in the VMX. So technically, there's no reason we couldn't migrate a template. But it's actually something we've not explored or tested yet.
Yes, I think you have to convert it as a VM first, and then you can migrate it. If I remember, if it's like IMS, that's probably. But we'll take it back. That's a good question. We should test that. Another question was like, what tool you use to create those flow diagrams? I think it's Lucidchart, right?
It's Lucidchart.
You got some good comments on how good looking your diagrams are. I think the other ones are already answered. Can we handle VLANs, right? So that was like actually what we map is actually the VMware and KubeVirt networks in this case. So that's why you have to map them so that we know that let's say VLAN 100 on one side is VLAN 100 on the other side. Like just for you, like we only see the names that the hypervisor sees. So sometimes if they don't have the same name, that's actually the main reason why you need to map them from a network and storage point of view. Same thing. Another question that just came up is once imported, the image used by the VM, will it be stored within the OpenShift container registry? Can you answer that question, Fabian?
No, it's actually using a PVC. So we don't import an image. We actually import the disk of the VM. So each disk is in a separate PVC. So if we wanted, it would be possible actually to generate an image from the VM. I know that KubeVirt is able to import images, for example. The trick here is, well, you could actually choose another path if you wanted to use registry. You could run the migration with Virt V2V to generate the QQ images for the disks and then push them in the registry if you wanted to use it for templates, for example, inside of OpenShift. We've not tried that directly from MTV. Or Forklift. I'm not sure what the use case would be behind it. I'd like to understand a bit more the use case.
Hey, one more question I missed, Fabian, is does this handle multi-NIC VMs? The answer is yes, but especially those with vSwitch configs.
With vSwitch, well, we support both standard vSwitch and distributed vSwitches. Here in our lab, we mainly have standard switches. It's a small lab with only 2 nodes, so we didn't want to have the overhead of virtual distributed vSwitch. But yeah, the other thing is in OpenShift virtualization or KubeVirt, you can't have 2 NICs on the same network for the VM. Actually, the reason is basically the same as you would have for VMware. The high availability is at the hypervisor level. So if you're connecting your network, if you're creating your network in OpenShift, you can actually use a bond or 2 interfaces with high availability. That's the same in VMware. So usually we only have 1 NIC per network, and we enforce that on OpenShift virtualization. But we can fully have a VM with 2 NICs or more on the migrated using Forklift.
I think that's it from a question point of view. You are at 18 gigs over 20 right now, so it looks like it's still copying.
Yeah.
Somebody saturating your network in your lab?
No, it's more about the number of layers we have, because we're running on top of OpenStack. So OpenStack is we're using nested virtualization in our VMs, and then exposing that nested virtualization inside of the OpenShift virtualization layer. So it's more about the number of layers we have rather than the real network performance. Well, and we're also sharing with a lot of people the underlying network, but I think it's 2 times 10 gigs, so we're not consuming that much.
Sounds good. So yeah, so I think that's good for anyway. We'll trust that the migration will complete with 1 gig away. Like you guys will just see like a green icon at the end. So, but that was pretty much how the tool works. So maybe if you can come back to the slides, and we'll give it back to Jonathan, Fabian.
Sure.
Thank you guys so much for that. There was one question by Jeff Warnica. He asked, the target pod then is a generic VM runner image and particular QCal2. I'm not too familiar with that last term.
It's not QCal2, it's a raw format. one of the limitations we had with KubeVirt, who supports only row. But still, we're not copying all the data, so there would be a lot of zeros in the disks. So even with row, you can have empty sections in the disk.
Okay, awesome. And it looks like Marco got the rest of the QAs. And just going over the polls. So one of the poll questions was, who do you see as a primary consumer of KubeVirt within organizations? 83% said operations, and 13% said both. So those are your two highest ones. And then the second poll question was, what kind of virtual machines do you see migrate into KubeVirt? And Windows VMs got 10 votes. Linux, which is 48%, Linux VMs got 48%, and other was 4%, which other really just means both in this case.
It means we need both. Yeah.
Yeah.
That's good.
Yeah, that's my mistake. Sorry.
And I think that's it. So guys, thank you all for attending. If you can, there's a link to the survey right here on this slide and also in the chat. If you can fill that out, that will help us understand better what topics we need to hit on and how we're doing. And also, if you're not subscribed already to the group, the Google group, please go to Konveyor.io, click on forums, and then click on join group. So until next time, thank you guys. Enjoy the rest of your Friday. Bye.
Thanks all. Thanks, Fabian.
Thank you.